Our formula is very different from additional formula, and triple identity is about solving theta. Okay, for example, where we have some constant sine of theta plus e cosine theta goes to some constant c. Okay, now we need to solve for theta. Combine this into a single trigo function such that we'll end up with theta equals to perhaps sine inverse of c. Okay, so that's how we need to do and solve theta. So some very brilliant guy look at additional formula. So in particular, he looked at this. So he saw a pattern, okay, in this additional formula. Oh, okay, he saw that when two terms add together will give us a single trigo function, and therefore after that we can take the inverse of the trigo function to find the angles. So maybe he look at a single case like, okay, this let's say theta plus 35 degrees. So after he do the additional formula, you'll get this. Okay, and then he worked out this particular example. Okay, and this is very similar to the one in general that we need to solve. So from here we can see how to solve. So let's say it's equals to some constant c. Theta will be, okay, take sine inverse of c. Okay, bring the 45 over, and theta is solved. Okay, so this brilliant guy came out with this from the additional formula. He saw a pattern, and this will become the R formula. Here I'm going to show you the proof on how to derive what is R and what is the acute angle alpha. So we have established that A sine theta, this is a generic form, cosine theta, so this will be R. So we know that from the earlier slide this will be in this form because we want to solve for theta in a single trigonometry function. So this is from the additional formula. So alpha. Okay, so we need to now determine what is R and what is alpha. This is our unknown that we need to solve. So there's no need to determine this yet. Okay, so first we expand this form using the additional formula. Okay, this keep the constant. We expand this using the sine additional formula. It will be as such. Okay, open up the bracket by multiplying the constant R into everything. Okay, from here, okay, we have to do compare coefficient. First term, this A we need to find. Okay, it is with cosine theta, so A will be R cosine alpha. Okay, this is by comparing coefficient. Pretty simple. Likewise for B, since cosine is already there, the rest will be B. R sine alpha will be B. Okay, so what's the purpose of this? Again, we go back to what we need to find. Find R and find alpha. From here, okay, if we do a division, okay, we will be able to find, we will eliminate R, we'll be able to find alpha. This is something like solving simultaneous equation. Okay, okay, so R and R will cancel. Sine over cosine is just tangent alpha. So to find alpha, take tangent inverse of B over A. Okay, so alpha solved. Now left with R. So over here, there's a pattern. If you recall the identity, cosine square plus sine square will give us 1. So we need to square this, okay, to try to see if we can use the identity to give us 1. So R square square alpha. Okay, so we factor out the common factor. So cosine square plus alpha will give us 1. So R, we take the positive square root because it's defined as a positive value. Okay, so R is found. So basically, for any general form of trigonometry functions like this, to find the alpha, the acute angle, some value is tangent inverse of B over A, that means the constant. To find R is the square of the A's and B's. So if you got other forms, you have other formulas. So in general, please memorize this R formula. Okay, when you have A sine theta plus B cosine theta, you have R sine theta plus alpha. When you have these two, then it's the minus, here will be theta minus alpha. When you have A cosine theta plus B sine theta, okay, since we start off with cosine, the R formula will be cosine. Okay, the proof, you can go and do it on your own. Okay, so here, take note, since its cosine is negative, so when you have the subtraction of those two, you end up with a plus. It is only for this case where your sign here is the opposite of what you have in front. Okay, but the R value is still the same, A square plus B square, positive square root, and tangent alpha is B over A, where this is an acute angle. Acute means less than 90 degrees. Okay, so next, let's look at how we can use R formula to solve basic problems. Okay, here they ask you to express this in terms of the R formula, hence solve this equation. Okay, so meaning we need to find what is our theta. So straight away we use the formula. So sine. Okay, take note here we're adding. So referring to the formula will be R. We start off with sine. So this will be sine theta plus alpha. we know that r is the square root of a squared plus b squared. This is a squared, this is b squared, so 4 squared plus 3 squared. That will give us 5. Next, tangent alpha is b over a. Alpha is tangent inverse. B is 3, A is 4. It will give us 36.87 degrees. Okay, notice intermediate working more than one decimal place. Okay, here the question asks us to express in this form. So do go and rewrite this into that form. 5 sine theta plus 36.87 degrees. Okay. Next, using the R formula, we have found out, hence solve this equation equals to 4.8. So this has some value, 4.8. So these two are the same. We need to solve for theta. Okay, here is just a simple manipulation. Okay, so our formula is actually quite easy to do. Okay, before you even jump into solving for theta, must take note of the range 0 to 360 degrees, and this value is positive. We need to look at the 4 quadrant first. A, S, T, C. So for sine, only the first 2 quadrants will be positive. So later whatever value we find will be in the first quadrant, and also must take note of the second quadrant. Okay, so there are 2 values. So theta plus 36.87 sine inverse 4.8 over 5. Okay, this will only give us the first quadrant. We also need to find the second quadrant. But first, let's find the first quadrant value. 73.74. Okay, the second quadrant, we take 180 minus this value there, which is 106.26. Now then we can find what is theta. Okay, theta is 30. Okay. So this is the final answer, therefore we need to round off to 1 decimal place. Okay, first answer found, second answer. So our formula is very mechanical. You just need to memorize the formula very well. Okay, done.